Hi everyone, in this video I'm going to be talking about chromatids, the second structural naming that we have for DNA. So chromatids are tightly coiled DNA strands. And when we're talking about these chromatids, we are referring to the eukaryotic cells. So this is linear DNA that gets all wound up. And these chromatids begin to form during prophase. And then they begin to unwind during telophase. And as they unwind, they go back into the chromatin form. So what you're going to see when I am talking about those chromatids are these tightly coiled, spiraled structures. And these, as I mentioned, begin to form during prophase. And the goal of these is to make the separation of the genetic material much easier than if the DNA were just in that chromatin form, which is loose. So this right here is the tightly coiled DNA in the form of a chromatid. And to make life easier, many times what you're going to see me draw is the chromatid like this. So it's going to kind of look like a butterfly, but understand that what I'm trying to show you is that within this is all the tightly coiled strands of DNA that have formed in prophase and will stay in this form throughout mitosis. In this way, it makes it much easier for the genetic information to be divided up. During the formation of these chromatids, it's important to note that this chromatid right here will have the exact same genetic information as this one right here. So in other words, this genetic information was copied during the S phase. And so the other chromatid that's attached to it is genetically identical. And in this form, the DNA is not accessible. You cannot read it to make proteins, and you cannot copy anything from this. This is why it only forms during mitosis, because then otherwise you would not be able to use the DNA. And that's it for this section. I hope this video was helpful. Thanks for watching. Bye.